Okay, so today we're going to learn composition of functions. I can find the composition of functions by using substitution. This should be brand new for what you're seeing. Okay, composing one function with another function is applying one function to the result of another function. The notation, so be careful with the notation. This is how it will usually be in the form when it's asking for composition. The first thing I do right away is rewrite it. Okay. So the first function is what is on the outside composed to the inside function. So the inside, the second function is the inside. So I rewrite this because it reminds me of substitution. What this is saying here is I want you to put in the function of g of x into every x that you see in f. Okay. Same thing. This is why order matters because g is now on the outside, f is on the inside. So for every x in G, I'm going to put the function f of x. Okay, so the other thing when you do composition, and on your practice work, you're not going to have to worry about domain this year, but next year you will. So it's nice to get familiar with the domain. Domain of the composition function is determined by the domain of the inner function and then the composite function. So you have to look at what's on the inside first, and then at the very end, what you end up with, okay? So when we're dealing with domain, we have two situations as of right now that we have issues with. And we're gonna go into more of domain with next chapter and everything, but I'm sure you can tell that there are a couple domain restrictions that we've done already in the past. So one of the domain restrictions we just got done with is that for rational functions, okay, rational functions, we can't have 0 in the denominator. So denominator cannot equal 0. Okay, that is the restriction. There's another function that we've done before in the past that can't happen, and that's with their square roots. Okay, so think of it right now as I'm writing this down. What can't happen with square roots? Well, we can't have, so no negatives. Under the root. So we have to keep this in mind when we talk about domain restriction, what x cannot be. Okay, so in example 1, we have f of x equals x squared plus 2x plus 1, and g of x equals x plus 5. So I'm going to find f composite g. So again, I rewrite this first, knowing that f is on the outside, g is on the inside. Then before I even do the composite, remember I have to, when dealing with domain, I have to look at the inner function first. So the inner function is this g of x. And as you can see, it's linear. It does not fall into the category of our problem issues. So right now our domain is negative infinity to infinity, all real numbers, because we don't have a problem. You'll actually hear me a lot say when we talk about domain, is there a problem? If there's no problem, it's all real numbers. If there is a problem, we have to do some solving. So right now we don't have a problem because it's linear. Now, I'm going to use a highlighter to help us visualize. So what we're going to do is we're taking our g of x function, and what we're going to do is substitute it in for every x I see in the other function. So I'm taking this whole function and I'm plugging it in for each of these x's. It's like substituting, right? So if this was 5, I would be putting in 5 for x, but instead I'm putting in the whole function. So my new function would be, instead of x squared, I'm going to have this x plus 5 squared plus 2 times, instead of x, I'm going to put the function g of x in there, x plus 5 plus 1. So I want you guys to recognize that this is in the same format. The only difference is instead of just x there, I have this function. So that's composition. Now, in most cases, it will then ask you to simplify to then look at the new domain. But in this case, if we look at this new function, is there a problem? No. And remember, what did I say the domain was if there's no problem? Because there's no rational or no square root. If there's no problem, the new domain is just all real numbers. So negative infinity to infinity. Now, just in case on your practice work, or if you went to like example, college algebra, and they want you to simplify, that means you're going to actually have to do this out. You're going to have to multiply here, distribute here, and then combine the terms. So I'm going to simplify this just for fun here, so that way you can see if you need it during your practice work. So simplify function. Once I multiply it to FOIL, to box, whichever way you want, I get x squared plus 10x plus 25. Then I'm going to distribute that 2, so I get 2x plus 10. And then at the very end, I have this plus 1. And what am I going to do to make sure that I'm all done? I'm going to combine like terms, and I end up with x squared plus 12x plus 36. Again, this is quadratic. That's not one of our issues. So the domain is negative infinity to infinity. All right, if it was that simple all the time, we would practice right now, but we've got to practice these different functions in case there are problems, or if you have to use more algebra to simplify. So there are two functions, and I'm going to rewrite this. F is on the outside, G is on the inside. Now I'm going to look at my G function to see if I have any domain restrictions. As you can see from G, this is a rational function. So we have to say, ooh, the denominator can never be 0. So what makes the denominator 0 here? 2. So that means x can never be 2, even when we simplify our composite function, okay? Now I'm going to use my highlighter. Remember, this is take the function of G and plug it in for every x and f. So we're taking the whole function of G and plugging it in for x. So I'm going to rewrite this. So I get 1 over, instead of this x here, I'm going to write this whole thing, x over x minus 2 plus 1. All right, well, I can't tell right off the bat if there are any domain restrictions right now, so I have to simplify. Well, just like we just did about a week or two ago, I have to combine this right here, and I have a fraction and a whole number there. How do I combine them? Common denominators. So this one's missing x minus 2. And whatever I do in the top, anything I do in the bottom, I do in the top. There we go. Okay, and then I can combine them. So what happens is I have 1 over, and then if I distribute that 1 out, I end up getting x plus x minus 2 all over that common denominator. I'm also going to put this down here because this fraction is together and this will help us later. Now I need to combine like terms. Remember, I don't cross out until my final step. Now let's go back to like a grammar school time. When we have a fraction divided by a fraction, what else can we do? Oh, we can multiply it by the reciprocal. So the reciprocal of this fraction is flipping it. And of course, anything times 1 is just itself. So this is our composite function, okay, or composition. So now when we think of our new domain, first of all, we need to think of the composition function to see if there's any problems. Well, what's the problem here? It's still irrational, so the denominator cannot be 0. So what makes the denominator 0? Well, 1. If you guys need to, set 2x minus 2 equal to 0 and solve. So x cannot equal 1. Okay. Now I have to combine these two problems together. X cannot equal 2 and x cannot equal 1. I am going to write this in interval notation just in case our practice work wants it. You have to be careful if it wants it, if it's just fine with saying that x can't be 1 and x can't be 2, or interval notation. So interval notation, we start with negative infinity, and the first value it can't be is 1. So we put parentheses there. Now we have to start back at that value of 1, and we go to our next value, which is 2. Start back at 2 and go to infinity. And that is our new domain. All right, you see something different in example 3. Well, if you see here, it's G composition F. So when I rewrite this, G is on the outside, F is on the inside. Okay, let's look. Are there any problems with the inside function of f of x? It's linear. That's not one of our problems. So we still have negative infinity to infinity. No problems. We're set to go. We get my highlighter. So that means we're going to take f of x and plug it into every x we see in G. So let's start writing this over. So 2, instead of x, we're going to say x minus 3. Now, this function can't be simplified anymore. So is it one of our problems, our issues, right? Our issues are rational and square roots. Well, no, there's no problem. This is exponential. So since there's no issue, our domain is all real numbers, negative infinity to infinity. Let's see what else they have for us here. Oh, look at, we're getting into our square roots. All right. Whew. Okay, so again, we have G on the outside, f of x on the inside. Let's look at our f of x function. It's a quadratic, so there's no problem. All real numbers still. So now let's do our composition. So we're going to take f of x and plug it in for every x we see in G. I get the square root, and instead of x, I'm going to say x squared minus 1. And there's nothing that we can actually worry about here right now. So this is simplified. But when we talk about domain, we have to think about what doesn't work. And as you can see, we have a square root here. So what do we know about square roots? Well, what's under the square root cannot be a negative number. So it has to be greater than or equal to 0. So let's solve. So x squared greater than or equal to 1. Take the square root. But when we take the square root, we end up with a positive negative. So watch this. When we take the square root of both sides and we have a positive, we keep the sign the same. But when we talk about taking the square root and doing the negative, you actually have to switch the sign. So what is this telling you? X has to be greater than 1 and X has to be less than -1. So if you picture that right now, what's happening, guys, is at 1, it's going like this. And at -1, it's going like this. And you can test that on your graphing calculator to see that graph. So when we talk about our new domain, we don't have to consider the original function of f because we said it was all real numbers. But now, as you can see, nothing can happen in between -1 and 1. So we're going to go negative infinity to -1, that lowest value. Now it can be -1, so it's going to be bracket. And then the next number it can be is 1. It goes all the way to infinity. Again, if you are not understanding the domain stuff right now, it is okay. I just want you to be familiar with it and introduced to it. On your practice work, there will be just the composition stuff, not the domain. When you get into college algebra, then there will be the domain, okay? All right, here, look, we have the same functions, but as you can see, we're going back to f of g of x. Okay, so now we do have to consider that inside function, and our inside function is square root. So we do have a problem, right? X can never be negative, so X has to be greater than or equal to 1, or 0, sorry. There we go. So I'm just going to keep that there as a reminder for when we do our new domain after. All right. Let's look at g of x, and every time we see an x in f of x, we're going to replace it. So instead of x squared here, I have the square root of x squared minus 1. Okay, I need to simplify. Well, when I simplify, what do we get? We get x minus 1. So if I look at this composite function, do we have an issue? No, we don't. Don't think about all real numbers though, because we did have an issue to begin with. So that means our new domain has to deal with those issues. The issues is that x has to be greater than or equal to 0. So putting it into interval notation goes from 0, and it's a bracket because it can be 0, all the way to infinity. Here's a couple more composition ones. I love it when we do compositions of evaluations, specific numbers, because it's a little bit more easier to simplify. But still, the first thing I do is rewrite this. So we're going to say f of g of -2. So I always work inside out. So we're going to focus on g of -2 first. And if you remember, g of -2 means we're going to replace every x in g with the number -2. So we have -2 from here. Absolute value of -2 plus 4 plus 5. Okay, -2 plus 4 is 2. Absolute value of 2 is 2. 2 times -2 is -4. -4 plus 5 is the value of 1. Now that's what I get when g of -2. But now with this value, what I'm going to do, because we're doing composition, is now I'm plugging that value into f. So every time I see an x in f, I'm going to replace it with 1. And then when I actually evaluate that, I get the value of 3, and this is my answer. All right, remember the order. This is g of f of 0. Inside first, so f of 0 I'm replacing x with 0 for the function f. Remember that you're grabbing the right function. If I simplify this, well, 0 minus 1 is -1. -1 squared is 1. 1 plus 3 is 4. Now, again, that's just f of 0. So now it's telling me to plug it into my g. But now I'm going to evaluate that at 4. -2, absolute value of 4, plus 4, plus 5. So 4 plus 4 is 8. Absolute value of 8 is 8. 8 times -2 is -16. -16 plus 5 is -11. If you have to use your calculator, go for it. Okay, this is kind of a different format, right? But it's just saying we're going in the function twice. So again, I'm still going to rewrite it. f of 1. Work my inside first. So f of 1 equals. Well, guys, we already did the math over here. So I'm just going to use that value. We know f of 1 is 3. Now what we do is we have to now replace it in here. So we're looking at f of 3. So f of 3 is 3 minus 1 squared plus 3. That equals, well, 3 minus 1 is 2. 2 squared is 4. 4 plus 3 is 7. Okay, we're going to practice that again down here. So this is g of -7. Let's do that inside first. So we have g of -7. So that's -2 times absolute value -7 plus 4 plus 5. Okay. -7 plus 4 is -3. Absolute value of -3 is 3. 3 times -2 is -6. -6 plus 5 is -1. So now when I replace this g of -7 with -1, what I have left over is g of -1. So now I'm going to plug that in. So -2 times absolute value of -1 plus 4 plus 5. So -1 plus 4 is 3. Absolute value of 3 is 3. -2 times 3 is -6. -6 plus 5 is -1. Whew. There we go. We just did compositions. Again, I know this is your first time seeing this. You will see it for the next couple of years when you do algebra skills. So just take your time with it.